Okay, welcome back to part 2 video of data transformations. Let's pick up right where we left off with relocating columns. So relocating is going to be reorganizing our columns, which is going to be a better way to do this than trying to use a select statement at the same time and put them in the right order. So this way I'm not going to drop any columns that I don't mention. So by default with this function, all of the variables are placed at the front, but we can change that by using either the dot before or the dot after arguments. And these arguments use a period in front just to signify that there aren't a column named before and a column named after. So this is going to be similar in the mutate function as well, which we will learn shortly. So for this example, if I wanted to take batting and I wanted to relocate home runs to the front, I could do batting, relocate, and use the default option. And now I have relocate, I have home run as the first column. Let's say I also wanted to bring league ID and games, but I wanted to put them after at-bats. So now I have league ID and games after at-bats. So a few different options for us there. I could use the dot before as well. Generally, it's a good idea to have all of the categorical information. So the player ID, the year ID, the team ID, all that stuff before the numeric information, which is exactly how our data set was set up in the first place. So there is an exercise for you to try. So moving on to the next task, which we should be familiar with conceptually, is going to be filtering rows. So imagine using Excel and manually specifying a filter, kind of using that drop down in the checkbox. That's what we're going to be doing, but now using functions to do that for us. So what filter does is check the row conditions based on a logical test. And this logical test uses one of the following operators. So we could have greater than or equal to, less than or equal to. That exclamation mark again is going to be not equal to. Or equal to, I have to use a double equal sign now. So one equal sign is for assigning, two equal sign is for checking equality. So let's say I want to find the player ID for Hank Aaron. So I want to get only the rows corresponding to Hank Aaron. So his player ID is Aaron HA01. And I'm going to do it with an error first. So I only have the one equal sign. When I do this, it says it even gives me a helpful error message. I need to use two equal sign instead. When I run that, it gives me just the rows with Hank Aaron. I could use a few other ones. So let's say I wanted to get only the most current year of data, or maybe some recent years. I could do filter, where my year ID is greater than or equal to 2020. And this is going to only give me some recent data. So I start with 2020 now. Or we could also get just the most recent year and do batting, filter, year ID equals, I can use functions in my conditions. So we can use functions of other variables. So I'm going to find the maximum year ID, see if the year ID for every single row equals the maximum for everything. And when I run that, I should just get 2022 data. And there we go. We can also check more than one condition at the same time. To do that, we can either use an and, so an ampersand, or we can use a comma, which is going to be the most common way to do this. So this checks for both conditions. So suppose I want to check for all rows. I want to get all rows that have the league ID equal to the National League. And, so I could do and my second condition, but it's more common to use a comma. And I also want them to be from the most recent year of data. So I want to get all these seasons from the most recent year from the National League. So when I run that, error here, so year doesn't exist. So I have to check year ID, so make sure you have your columns good. So I get just the National League from the most recent year, 2022. We could check either condition. So to check either condition, all we have to do is change this comma or ampersand to a vertical bar. So this checks or. So either I'm going to get National League or from the most recent year. So when I run this, I should start with some older players that were from the National League. If I were to continue to scroll through this, I would eventually get to the players that are just 2022. Another very useful operator is the percent and percent operator. So that is going to give us the values where, in this case, my percent, my team is in a character vector. So we use this to check for multiple values of the same variable. So I want to see if my team ID is within the vector Cincinnati, Philadelphia, or Miami. So these three, it's checking if my team ID is in percent is in this character vector. So when I run this, I should just get Philly, Cincy, and Miami teams. So that's a very useful operator. So then we have an exercise for us to try. So next up is going to be ordering rows. So this is going to be like sorting in Excel. So how do we do this? We do this with the function that is called arrange. So this arranges values, sorts our rows based on the values of a supplied column. And I can specify multiple columns, and each one gets sorted within the previous. So it kind of nests this sorting idea. And by default, it sorts ascending order for numeric variables. I can use descending by wrapping the column name in the function DESC for descending, and it sorts alphabetically for numeric or for character or factor columns. So let's say I wanted to take batting and arrange it according to year ID. By default, I'm going to get all of the older players first, listed from smallest year to largest year, 2022. I could also arrange it alphabetically. So let's say I want to get batting, arrange according to player ID. Now it's going to give it to me by player ID alphabetically, so starting with the AAs. And I could also do a kind of nested sorting. So in this case, order matters. So arrange by year ID, but I want to get the most recent years first. So I'm going to use descending around my year ID. And then I also want to have the most home run hitters first. So the highest home run hitters from the most current year sorted first. And need to have batting there. So I get the most recent year, and then within this, I get my hits, sorry, I get the most hits going from most to greatest. If I were to get rid of the descending, I would have all of the people with 0 hits and then going up to the top one. And this is within the 2022. Then it switches to 2021 and goes to the now the lowest hits all the way up to the highest hits within 2021. So there is another exercise for us to try. The next up is going to be finding unique rows. So to do this, we're going to use the function distinct. And what this does is essentially just removes all the duplicate rows. Often we use this to find the unique combinations of character variables in our data set, or even numeric variables. We're just finding all the unique combinations. And to do this, we just have to give all of our columns that we want to distinct. So for this one, I have a sample of the batting data where I'm just looking at the Cincinnati Reds for some recent years. So if I copy and paste this into my script here, I can take a look at the batting sample. So I just have Reds players from 2020 and beyond. So the first thing that we want to do is just take a look at the distinct player IDs. We'll use our batting sample. If I run that, it gives me all of my distinct player IDs. So this will tell me every single unique player that has played for the Reds in the last 2 years. There's a few different options that I could use in the distinct one. And one thing that I could do is keep all of the other rows. So notice that when I ran distinct player ID, it dropped everything else. If I wanted to keep everything, keep all. So notice that in our console or in our script here, R is very nice about autofilling our arguments. So this is a way to check to make sure that we have our right arguments. Then I can click tab and that brings that over. Set that equal to true. And now I keep everything else for just the unique rows. And notice that this keeps the very first occurrence. So it only keeps the very first row that it sees for this particular player. So this player might have, if I take a look at the batting sample, and I sort it by player ID, this guy also played in 2021, but I only get the 2020 row from distinct. So it finds the very first occurrence based on however the data is arranged. So that is how distinct works. So there is another exercise for us to try. Next up is going to be a very common one that we're going to use a lot. It's called mutate. And this is when we are creating or editing columns. So we're creating new columns. They can be just simple algebra, or they can be based on functions of previous columns, or even functions of themselves. So this is going to be a very, very useful function. So for example, let's say I wanted to take batting and I wanted to calculate the batting average. So I specify my new column name. So it's going to be, I'm creating a column named BA for batting average. And I want to take the hits divided by the at-bats, and I'm going to round that to 3 decimals. So when I do that, and I scroll all the way to the end here, I get my batting average column created that wasn't there before. By default, it always places it in the end of your data frame. We can change that, which I'll talk about next. We can also create multiple columns at the same time. So if I do a comma, and then let's say I want to change my team ID, I want to make all these lowercase. So what I can do is I can overwrite my current team ID by making it into a string to lower of team ID. So it's going to take team ID, convert it to a lowercase string, and then put it back into team ID. So I'm overwriting this column. So this function string to lower is a part of the stringer package, which is very, very useful for working with strings. So occasionally we'll have some problems where we are manipulating strings, and it's going to be very helpful to look at these cheat sheets, and it gives us lots of different functions for taking substrings, subsets of the strings, starts with lots of different functions. So wanted to point out that useful package for us. So when I run this, I get all of my team IDs now as lowercase. So that's how we can use mutate. And I mentioned that we can control where these new columns get placed. And the way we do that is the same way as with relocate with our dot before and dot after. So let's say I wanted to place these, but I wanted to place them right after my first column. So right after player ID. I run that, I get player ID. Now I get my batting average. But notice my team ID stayed where it was. That's because it was already a column. So if it overwrites a column, it just keeps its position. But if I were to have a new column that was new, then it would be right alongside batting average. So that is going to be the basics of mutate. So now let's look at some more advanced options. And the first one has to deal with what columns that we keep in the result. So by default, what happens is it really sets dot keep equal to all. So if I take a look at my documentation for mutate, the way we read this is mutate my dot keep argument. The default is going to be the first one that's listed, or the only one that's listed. So by default, dot keep is set equal to all. And these other ones have null values. So by default, when I run this, I get every single column that is returned. There's a few different options that we see in the documentation here. We can have used, unused, or none. And here's what these do. So if I change this to used, I only keep the columns that I specifically mention in my mutate statement. So I mentioned H, I mentioned AB, I mentioned team ID, and I created a batting average. Those are the ones that I keep. I only keep the ones that are used. It drops everything else. I could also do unused. So this drops all of them that are involved and keeps the rest. So it's just the opposite. So now I'm going to have all of those variables except the ones that I created, which maybe isn't very useful, and then except the ones that I referenced. And then one common one is only keep the ones that I create. I can change this to none, and this only keeps the ones that I am creating via this mutate statement. As far as specific functions, specific patterns that are going to be very useful for us, we can use if else and also case when. So if else and case when are going to be two very useful patterns for us to use with mutate. So the way if else works is I check my condition, I return a value if it's true, I return a value if it's false. So let's try that one first. So I'm going to take my mutate statement and I'll call this 30-30. So a common baseball stat is going to be, can you get 30 home runs and 30 stolen bases in the same season? So to check that, I would want to do, so I'm calling my data set 30-30, and I'm going to create a variable named 30-30. And it's going to be if else, my condition is home runs at least 30? And I can check multiple. So this time I'm going to use an ampersand. So my logical test is home runs greater than or equal to 30? Is my stolen bases greater than or equal to 30 as well? It's going to check this condition for every single row. If it's true, I want to return the value yes. If it's false, I want to return the value no. So when I run this and I check my 30-30, I can sort by my 30-30. And if I scroll down, see all the yeses and see where it converts to no, this was only done 63 times. So in the history of baseball, this has only been done 63 times. So it's a pretty rare club to be in this 30 for 30 club. So that is going to be how we use mutate and if else. Another very common one is going to be case when. So this is useful for when we're checking multiple conditions. So if else is kind of just for checking one condition, I'm either returning one value or another value. This time I want to check multiple conditions and return a different value for each of those conditions. So I have two different character vectors set up here. The first one is for my favorites. The second one is for my dislikes. So I have these favorite teams and I have the teams that I don't like. I want to check for every single row, every single player, are they in my favorite team or are they in my dislike teams? So the way we're going to do this is I'll create a column named my teams. And I'm going to set it equal to case when. And then I'll open that parenthesis. And I will space it out a little bit. So I'll drop down to a new line. So mutate case when. How we do this is I check my condition. So is my team ID in my faves? So this is the logical test. So it's my condition one, and then we do the tilde for a formula. So is the team in my favorites? Yes or no, true or false. If it's true, return the value favorites. So I'm going to return the character string favorites. Then I'm going to check my second condition. Is team ID percent in percent my dislike? If that's true, I want to return the character string dislike. So it checks these kind of sequentially. So it checks all the rows for favorites, assigns the value, and then it drops down and checks all of the rows for dislike. It drops down. So I still have a bunch of rows remaining that didn't meet either of these conditions. So this is kind of like if, and then this one is kind of like if else. And then if I want to have an else row to meet everything else, what we can do is we just set our condition to true. So I just want this to evaluate to true for everybody else. And it's kind of checking it sequentially. So this is doing exactly what I want. And then I'll set it to neutral. So for everybody else, just set this value to neutral. When I run this, I can scroll over to the end and I get a bunch of my teams and it checked. So the first rows were team TRO. That's not in my favorites. It's not in my dislikes. So it's going to set it to neutral. So that worked as desired. So a really long exercise for us, but this is going to be very helpful. So definitely want to make sure you work through this one. So next up is summarize. We will pick up with this in part 3 of this video.